A reaction that we overlooked was this. If I take an alkene, right? If I take an alkene, treat it with HBr in CCl4, and we can easily say that this gives, as Markovnikov ordered us, have bromine goes there and H goes there, right? This is what we call Markovnikov product. This is Markovnikov product, and by definition Markovnikov said H goes to the less substituted carbon, bromine goes to the more substituted carbon. But however, if HBr is treated, HBr is reacted with an alkene, an unsymmetric alkene, in presence of peroxides, you get anti-Markovnikov product. That means the same reaction, if I carried out the same thing, if I have HBr and throw a little bit of hydrogen peroxide by mistake, again, this must have been accidental discovery. And normally people work in the presence of light, doesn't have to be any special condition, and same solvent, we didn't use water or anything. This person, whoever studied this, found out bromine ended up adding here and H added there. So this is why they call anti-Markovnikov, because this is opposite of what was expected, right? So somebody has to come up with a story for that. We don't know. We just took this, added this, we got this. But if we simply added this, we would have gotten this. So how did this happen? This is an abnormal behavior compared to a predictable behavior. Why is this? How can this be predicted every time if I did that? Well, obviously the light or peroxide is the message. Whenever there is a peroxide, peroxides can be HOOH or ROOH. Now, if you ever went to drugstore, and looked for peroxide in drugstore, it is always stored in amber colored bottles, dark bottles. Do you know why they save it in dark bottles? Because this is light sensitive. These are light sensitive material. That means what? If the light comes along, this OO bond splits into radicals. And this is what one of the issues that people have to deal with if you come across hydrogen peroxide in presence of ultraviolet light. It can do some adverse reactions. Hydrogen peroxide can be used as disinfectant, and for the same reason, because when it comes in contact with light, it breaks radicals and it starts disinfecting the infected space. So that means this must be radical reaction. Whenever there is a radical pathway, there is no cation, no anion, only radicals, right? That means now we have initiation, propagation, of course two of them, and then termination. Typically there are many choices, 3 or more possibilities, right? So how do we approach this radical pathway? Well, H2o2, let me take that instead of ROOR. It could be ROOH or ROOR, it doesn't matter. Dialkyl peroxides, hydrogen peroxide, benzoyl peroxide. You know about the compound that is used for pimple cream or removing acne is this. Acne is also a radical process. Treating acne, proactive, which is used as a pimple cream, it contains this molecule. This is called benzoyl peroxide. Benzoyl peroxide, because of this peroxy bond, when it is exposed to air, it forms radicals. These radicals essentially go and kill the acne-causing microbes, and that's how you have acne treatment. Proactive is one of them. That's a trade name. I'm not going to talk about it. But this is usually used in anything that is used for facial creams or facial cleansing processes. Okay. So benzoyl peroxide is the cream that is typically used for acne. All right. So what is happening? If I take H2O2, initiation would be in presence of sunlight. You have this bond is highly labile, highly unstable. It's going to break, and you see the arrow is going to be single hook because we are talking about one electron walking away. So you have a HO dot and OH dot created. And that's the beginning of the fire. Now this HO radical then starts the fire. This HO radical reacts with the HBr, because that HBr is now destroyed by grabbing that hydrogen and creating a bromine radical. Right? This bromine starts making a number now. So this is where the initiation, there are two initiations that happened. Now propagation. Propagation would be, if I take an alkene and bring bromine next to it, so since there are two electrons, bromine is going to demand one of those electrons to come along. This has two choices now. Remember, since there are two carbons involved, this is a regio-selection, regiochemistry. What would happen? If carbon and this bromine start getting married with each other, now you will have that radical is created. Is that correct? But if this carbon and this bromine get married, this radical created. Do you notice that? See, there are two electrons here. Right? If one of the electron is used to make a bond here, the second has to go sit there. Right? If this is used to make the bond there, this has to go sit there. If this is used to make bond there, this has to go sit here, not there. So these are two possible radicals that we can make. Right now we have a choice. This is a tertiary radical. This is the primary radical. Boom. Case closed. Tertiary radical wins hands down. And we know that tertiary radical is probably 10 to the 6 times more stable. Tertiary is more stable compared to primary. We know that. So we already made a choice. This is not going to happen. So this is going to happen. There goes the Markovnikov business, because Markovnikov said the bromine goes to the most substituted carbon. In this case, we just happen to get less substituted carbon. There goes the Markovnikov rule. Already violated. Well, what next is propagation 2. So let me rewrite the propagation 1. Propagation 1 is bromine radical, demands that one electron come from here. it'll use its electron to make a bond there, and this electron, one electron sits there. Remember, there are two electrons in a pi bond. What do we get? And we already made the regio selection. We get this radical. This is propagation 1. Propagation 2 then has to be this one, reacting with HBr. Now this radical demands that hydrogen come with one electron and create a bromine radical. That's the rule of propagation. What is the rule of propagation? Whichever radical is used in step number 1 has to be reproduced in step number 2. And we did reproduce bromine radical in step number 2. And that goes back into step number 1. These step 1 and step 2 are going to go in cycle, finish the entire reaction. Then comes termination. Who are the candidates for termination? Well, in this reaction, we had HO radicals, we had bromine radicals, we also had that radical. Those are the three radicals that we came across, right? That radical, and that radical. We did not make any other radicals in this game. We did not make this radical either because this wasn't stable. So the only radicals available are hydroxy radical, bromine radical, or this tertiary radical containing one bromine. So these three can make 6 possible choices. What are the 6 choices? HO dot with HO dot, HO dot with Br dot, HO dot with that dot, and then Br dot can react with Br dot, Br dot can react with that, and then lastly that react with another that, right? So these are the 6 possible termination processes. Each of them have these arrows going this way, this doing this doing this, right? Mechanism means you got to show all arrows. Single hook, by the way. You cannot do double hooks. Same way. Frankly, we don't really have to, but since we have started, I'm going to show all the products. In this case, HOOH. This is going to be HOBr. It's going to be HO boom boom Br. It's going to give you Br Br, and this is going to be Br. I'm just following the molecule, and then finally right? So those are the 6 possibilities. Right? We don't really have to fuss over it. Termination means killing it. It's like a fire that you have to extinguish, because we don't keep the fire forever. Ultimately, what we focus on is this as our product. So let's not forget that we started with this. And we were expecting, according to Markovnikov, if it is HBr-CCl4, we were supposed to get this. That's a Markovnikov expectation. But if the process is contaminated in presence of peroxide, since there is light always available, our product turned out to be this. And this is the anti-Markovnikov. This is why, this is the explanation for why do we get anti-Markovnikov product. This is Markovnikov expectation. Right? That's where this story ends. Now, there are plenty of places where we should be able to look for test material.